All right, let's look over the questions from exam two. So first three are multiple choice. I'm going to leave the choices off while I work through them. So this ice cream shop has 925 different flavors. So if you can choose any one of those, so basically you have three different choices here. So assuming you can choose from 925 flavors and you have a choice of basically three different like containers, a cone, a cup, or a sundae. And there are 12 different toppings you can choose one of each from. Basically, what you have here is a lot of ways you can look at this, but you can kind of treat this as, you know, you have three different combinations to choose from. One of them is going to be a combination of among 925 things, I'm going to choose one of them. Then next, of a combination of a list of three things, I'm going to choose a combination of one. And then finally, of a list of 12 things, I'm going to choose a combination of one, which is equivalent to just multiplying 925 times 3 times 12, which is equal to, what did I write there? 33,300. 33,300. So that's how many total, basically distinct things you can get from this ice cream shop. All right, moving on to question two. So a bag contains three marbles, two green ones, one lavender, two yellows, three orange. And I'm going to make sets of 5 marbles. So what is implied here? Am I going to do permutations or combinations? It doesn't look like they're implying any kind of arrangement or order. I don't think I care about that at all. So I think because of that, I'm looking at combinations. So because of that, that'll factor into my calculations here. So let's kind of take a list of what I have here. I have 3 red, 2 green, 1 lavender, 2 yellow, and 3 orange. How many sets of 5 marbles include at least at most one of the yellow ones? So a couple ways to do that. So um basically let's do this first. How many combinations can I make? So how many marbles do I have? I have 11 total. So how many combinations can I make? So I can make 11, choose 5 combinations, total combinations. I don't care about all of them though. I only care about the ones that um, have at most one of the yellow ones. So there are a couple different ways to look at this, and I'll go ahead and work through both of them. But one of them is that, well, at most means that I have two, basically I can look at two different scenarios. One is 0 yellow, and the other one is 1 yellow. And since these are mutually exclusive situations, I can find these numbers of combinations and add those together. So let's do that first. So how many combinations have 0 yellow? Well, if I avoid both the yellow, then what I really have is 9 combination 5, because 3 plus 2 plus 1 plus 3, that's 9 marbles. I'm going to choose 5 marbles from those. Um, basically, I'm choosing, yeah, so that's the number of combinations I'm going to have. What if I want to choose 1 yellow marble? Exactly 1 yellow marble. Then that means that, let me just write this down as spaces. There's a yellow marble. Now, I'm going to choose 4 marbles to make up the other 4, but how many options do I have to fill those? I believe I have, well, I mean, you might think, okay, I chose a marble of the 11, so I have 10 choices left. except the other yellow marble is off limits to you. So I really only have 9 choices here. So one option here is I could do 9, choose 5, plus 9, choose 4, and that'll give you an answer. Another way to look at this is, now I only have 2 marbles. What if I find the number of combinations where I choose 2 yellow, like the only 2 yellow ones there are? So yellow, yellow, and then I got to choose 3 marbles. So I'm going to choose 3 marbles from a list of what? A list of 9. So these are the off limits combinations to make. So from here, if I find the number of off limits combinations and subtract that from the number of, total combinations with no restrictions at all, that should give me an answer as well. Both of those methods lead you to the answer, which is 378. So there are 378 combinations where I choose one yellow marble or no yellow marbles, but not 2. So moving on to part 3. So the following table shows the results of a survey of authors by a publishing company. What percentage of unsuccessful authors are new? So we're implying 2 sets here. One is unsuccessful authors, and one is new authors. So the unsuccessful authors are in this row. The new authors are in this column. So how am I, what probability am I really looking for here? So what percentage of unsuccessful authors? So I think I care about what the number of unsuccessful authors are, and that is 70. I also care about what the number of, do I want the number of new authors? Not exactly. I want the number of authors who are new and unsuccessful. That number is 11. Right. I'm not looking for the percentage of unsuccessful authors as a proportion of new authors. That actually wouldn't make sense. That'd be 70 out of 14. Or no, I'm looking the wrong way. But either way, that's not what I'm looking for. So the probability I'm looking for is this. So of the unsuccessful authors, which of those are also new? Like, we don't see the word also in here, but that's kind of implied in the question. If I'm looking among the unsuccessful authors, then I want to consider the new authors, but I don't want to consider the new successful authors, just the new unsuccessful authors. So this percentage is going to be found by dividing 11 by 70, which is approximately what? I just wrote 11 over 70. So I think the choices were actually written down as decimals. So I'm not sure if they were decimals or percentages. So it's either 15 or 0.1571 or 15.71%. Really, all 3 of these are perfectly acceptable. I just can't remember what the multiple choices looked like. All right. So question 4 is a free response question. All right. So the probability that a person in the US would declare bankruptcy in a certain year. Okay. So this is kind of a gloomy question. So the probability of bankruptcy is equal to 0.0004. Nope, too many zeros. 0.004. Okay. The probability that a person in the US would declare personal bankruptcy and had experienced a big 3 event. So they lost their job, they had some kind of medical problem, and they got divorced or separated. So that probability was 0.03. So we got to be really careful about the way that's worded. So I'm going to write this based on the way that is worded, verbally. I'm going to capture that mathematically this way. The probability of bankruptcy intersect big three. Because that is what this question says, or what this statement says. The probability that a person in the US would declare personal bankruptcy and had a recent big three event. So basically, that's the probability that both those happen, not just one or the other. So that is 0.003. What was the probability that a person had recently experienced one of the big three events? Given that they had declared personal bankruptcy. Okay, so now this is not exactly what so the thing we're being asked is a little bit different from what was being given. This is going to be a conditional probability. So bankruptcy is a simple event. That's just the probability of one event. Bankruptcy and a big three event, that's the probability of an and. That's the probability of an intersection. The thing we're being asked about here is what's the probability of, which direction does it go? What's the probability of a big three event given that that person had also declared bankruptcy? So in general, how do we calculate things like this? So a formula we've seen in the notes and on the videos before. The probability of A given B is equal to the probability of A intersect B divided by the probability of B. So we're going to kind of follow that same mold here. So equals the probability of bankruptcy. Should have really abbreviated these phrases. Bankruptcy and big three, or intersect big three, divided by the probability of bankruptcy. So what are these individual probabilities? So the probability of the intersection is 0.003 divided by the probability of bankruptcy on its own. So simplify this, what do we get? Essentially 3/4 or 0.75. All right, moving on to question 5. So according to a certain news poll, 63% agreed that it should be the government's responsibility to provide a decent standard of living for the elderly. So I'm going to call that probability living. So that is 0.63. And 45% agreed that it would be a good idea to invest part of Social Security taxes. Okay. So probability of Social Security, that is 0.45. Okay, what else do we know? If agreement with one of these propositions is, this is a key word, independent of agreement with the other, what is the probability that a person agreed with both? Okay, so these are totally independent. So how do we find the probability that they agree with both? That's going to come from multiplying these things together. So what is this probability? Living and Social Security. That'll be equal to P living times P Social Security. So 0.63 times 0.45, which is approximately 1. And instead of round to 2 decimal places, that comes out to 0.29. All right, and that's all for exam 2.